Hey everyone, let's dive into something kind of mind-bending today, shrinking down those massive AI brains, those LLMs, without, losing any of their intelligence along the way.
Yeah, it's a tough one. A lot of researchers are banging their heads against that wall because right now, using these really powerful AIs is kind of like, well, it's like trying to power a whole city on just a couple of AA batteries.
So you're saying it takes a huge amount of power to make these LLMs work, and that makes them really impractical for everyday use.
hmm
I've been seeing a lot about this new technique, SeedLM, I think it is. It's generating some buzz. What's the deal with that?
Okay, so imagine this. Instead of having this massive library of information, which is basically what these LLMs are doing now, right? What if you just had like a secret code, a code that could recreate any book in that entire library perfectly?
Whoa, okay, that's getting a little matrix for me, but I think I kind of get it. So that's what this SeedLM thing is all about.
Exactly. See, usually these LLMs, they store information in these huge, I mean, huge D spreadsheets. We're talking billions of cells. That's a crazy amount of data. What SeedLM does is it basically finds a specific code, a seed, for each section of that spreadsheet.
Instead of saving the whole spreadsheet, it just saves a tiny little seed, which is way, way smaller. Kind of like instead of storing every single cake in the world, you just have the recipe for any cake you can imagine, right?
You got it. And the best part is that recipe, that seed, it can perfectly recreate that original information whenever you need it, which is, well, it's a pretty big deal if we're talking about making AI accessible, you know?
Yeah,
Yeah.
definitely makes sense. But I got to ask, how does SeedLM actually find these magic seeds? It's got to be more complicated than just like random guessing, right?
Oh, absolutely not random. It uses this really cool thing called a linear feedback shift register, or LFSR for short. If you want a picture, think of it like a lock and key kind of system.
So SeedLM is going through all these different keys, different seeds, and just trying them out until it finds one that unlocks a perfect copy of that part of the spreadsheet.
That is a fantastic way to put it. It basically tests out millions, billions of different seeds really, really fast, and it's searching for the one that generates the exact same pattern as the original data. And because these seeds are so tiny, it can test a ton of them super quickly.
That's incredible. I mean, it's like SeedLM is this massive supercomputer crunching numbers and finding these perfect seeds to unlock like the full power of AI or something.
That's a great way to think about it. And get this, they've already begun testing SeedLM on some existing LLMs, and the results are really promising, especially when it comes to speed. Early tests showed that SeedLM made these AIs up to 4 times faster for stuff like generating text.
4 times faster.
Wow.
That's wild. Imagine having a conversation with an AI that's as natural and quick as talking to another person, No lag or anything.
Yeah, that's the kind of future this could lead to. And to really understand how SeedLM could work on AI that's already out there, researchers decided to try it on Meta's llama models. These are some of the most advanced LLMs we have.
Yeah. Llama models. I've heard of those. They're really powerful, right? But they're also like massive and really complex.
Exactly. They compressed these models with SeedLM, and get this, they shrunk them down to just 3, maybe 4 bits of information compared to the original 16 bits. And here's the kicker, they were able to keep almost the same level of accuracy.
That's crazy. It's like, I don't know, taking a whole season of your favorite show and compressing it down onto like one of those tiny flash drives. But you don't lose any of the episodes or anything. What about that new Llama 3, though? I heard that one was way harder to shrink down.
You heard right. It seems like the more advanced the AI gets, the trickier it becomes to compress it without, sacrificing some of what it can do.
So does that mean we're going to hit a wall at some point? Like, is there a limit to how much we can shrink these AIs without them just, I don't know, becoming kind of dumb?
Yeah, it's definitely a challenge, no doubt. But the interesting thing with Llama 3 is, even though they couldn't shrink it down quite as much as those earlier versions, SeedLM still managed to compress it.
Yeah.
Which, that at least suggests there's still some wiggle room, some potential to make things even smaller.
So there's hope for even tinier AIs down the line. Maybe even small enough to live on our phones or like even smaller gadgets and devices.
Precisely. That's the really cool thing about SeedLM. We're not just talking about like shrinking AI just to shrink it. It's about making it way more accessible for everyone.
Because right now, not everyone has a giant supercomputer just sitting around to run these massive AI programs, right?
Yeah, exactly. And that's where that other big advantage of SeedLM comes in. It doesn't need any of that extra training data to work its magic, which is pretty huge.
Now, you've mentioned this whole data-free thing a couple of times. What's that all about?
So a lot of other compression methods out there, they're kind of like they're like apprentices, you know. You got to train them on a specific set of data first, like show them how it's done before they can actually start compressing anything effectively.
So they're learning by example.
Yeah, exactly. But SeedLM, it's more like walking in as a seasoned expert, you know, like it can just stroll in, analyze that LLM structure, find those perfect seeds, and bam, compress the whole thing without needing any help.
Okay, that's seriously impressive. No training required. It just jumps right into shrinking these AIs down. But if it's not actually learning from extra data, does that mean it's just using what's already in the LLM itself?
You got it. It's like, I don't know, some kind of master code breaker. It can spot all these hidden patterns, these relationships within the data itself. And that's a huge plus because it means SeedLM is incredibly efficient.
So what does that even mean for, like, a regular person like me? Why should I care that this SeedLM thing is data-free?
Well, for you, it can mean like faster downloads, smaller app sizes, you know, the things you actually use AI for, and quicker updates for all those cool AI-powered tools and stuff and all of that, without sacrificing any performance. No more waiting around forever for gigabytes of data to download, you know.
Now, that's something I can definitely get behind. Faster, smaller, and just as smart.
Yeah.
Yeah, SeedLM sounds like it could really be a game changer for sure.
It's got the potential, for sure. But, you know, there are still some hurdles to overcome, especially because these LLMs are always evolving, always changing. Remember we talked about Llama 3 being tougher to compress?
Yeah, because it's trained on so much more data, right?
That's it. And that's what makes this whole thing so fascinating. It's like this constant back and forth, this push and pull. Like the folks developing AI are making these models bigger and smarter all the time. And then researchers like the SeedLM team, they're coming up with these clever ways to shrink them back down so they're actually usable for the rest of us.
It's like an AI arms race or something, except everyone wins. So what happens next in this epic battle for smaller, smarter AI? What are these researchers focusing on now?
Well, it sounds like SeedLM is already a pretty huge step forward for AI.
It is, it is. But honestly, it's just the tip of the iceberg. This whole SeedLM thing, it's really opened up a whole new world for AI research, you know?
How so?
Well, think about it. If we can figure out how to shrink down these AI models this much, it could totally change how we think about designing the hardware, too.
Graham? Okay, now you're going to have to explain that one. What do you mean change how we design hardware?
Well, right now, we're basically trying to cram these huge AI models onto hardware that was never built to handle them. Like, I don't know, just trying to stuff a whale into a bathtub. It doesn't quite work, you know?
Yeah, I can see how that might be a bit of an issue.
Exactly. So what if instead of forcing AI onto hardware that's not really cut out for it, we started designing chips and devices that were built specifically for these smaller compressed models? So instead of the bathtub, we build an ocean for the whale.
Now you're getting it. Imagine chips so tiny, so energy efficient that you could have crazy powerful AI running right on your phone or like built into everyday objects even. The possibilities are huge.
Wow, AI and everything. That does sound pretty revolutionary. No more relying on the cloud or worrying about data limits or anything like that. But is that even realistic? We're talking about some pretty futuristic tech here.
Oh, it's a challenge, for sure. No doubt about it. But with all these breakthroughs, like the SeedLM thing, we're getting closer all the time. That's what's so exciting about all this, you know? It's not just about making AI smarter. It's about making it accessible for everyone. It's like democratizing AI, you know?
AI for everyone,
Yep.
not just the tech giants and the research labs. I like the sound of that. But if SeedLM is just the beginning, what's next? What are researchers focusing on now?
Well, for starters, they're always trying to improve SeedLM itself, right? Always looking for even more efficient ways to shrink these models down. Plus, they're exploring entirely new ways of representing all this information within LLMs, like moving beyond those massive spreadsheets to something even more streamlined. It's pretty wild stuff.
So it's like we're standing on the edge of a whole new era of AI, where these super powerful tools are available to everyone, not just a select few.
Exactly. And that brings me to something I really want you to think about. Just imagine the possibilities of having this kind of AI available everywhere. How do you think that would change things? How we live, how we work, how we interact with the world around us. It's pretty mind-blowing when you think about it.
Yeah, that's something I'm going to be chewing on for a while, that's for sure.
Yeah.
From shrinking AI brains to the future of intelligence itself, this has been quite a deep dive.
Yeah.
Thanks for breaking it all down for me.
Anytime. And remember, this whole world of AI, it's constantly changing, always evolving, so stay curious. Keep asking those questions, you know?